Good morning, everyone. This is Au3, working as postdoctoral researcher at Chungmu National University with Professor Sang-Min Chao. My presentation entitled Biofunctional Activity of One-Step Fabricated Hydrated Cobalt Carbonate Molybdenum Oxide Nanorods for Energy Storage and Conversion Applications. These are the brief outlines of my presentation, which includes introduction and further objectives, and then materials part, and at last the application part. So at the very beginning, we all know that the current energy crisis, due to the unsustainable nature and non-renewable conventional fossil fuels, we need sustainable and renewable solutions. And regarding that, we generally energy conversion and energy storage systems are considered. And in energy conversion systems, hydrogen can be regarded as a future fuel which has very high energy density, and it can be used in various purposes like transport, household and industrial forms. And this hydrogen can be manufactured by number of systems, among these nearly 85% hydrogen is produced through steam reforming, but that associated with carbon dioxide emission, which is detrimental to the environment. So water electrolysis is another alternative way to produce ultra pure hydrogen, and this water electrolysis system applications includes two half-cell reactions, that is hydrogen evolution reaction cathodic and anodic oxygen evolution reactions. But both these two processes associated with high overpotential, because water is a quite stable molecule and it doesn't split in its thermodynamic potential of 1.23. So we need excess energy, that is identified as the overpotential. So to reduce this overpotential, we need suitable electrocatalysts which can catalyze these reactions and faster their kinetics. Generally, platinum group based materials are regarded as the commercial or benchmark catalyst, but their high cost and low abundance limits their application in long term and also for large scale production. And among these two reactions, anodic OER is a 4 electron transfer process, whereas hydrogen evolution or HER is only 2 electron transfer process. And as this 4 electron transfer process, this is much more complex than the HER. So this is much more slower and also associated with more high overpotential than HER. So this OER process is considered as the rate limiting for the overall hydrogen production efficiency, and we are interested in this part. Next, the energy storage. We know that battery can give high energy density but low power density, whereas supercapacitors can provide high power density whereas low energy density. But for efficient energy storage systems for mobile applications and also transport applications and other various wearable electronics, we need high energy density as well as high power density. So we are focusing on asymmetric supercapacitors which can give high power density as well as considerable energy density. So now coming to the motivation part behind selecting our material, that is nickel cobalt molybdenate hydrate nanostructures. This group LUETL reported that cobalt molybdenate can show good rate capability but low specific capacitance, whereas the nickel molybdenate can show high specific capacitance and low rate capability. And they showed that combining these two materials in a hybrid structure, they can achieve high specific capacitance as well as good rate capability. In another work, this Danish ETL prepared nickel cobalt molybdenate nanorods through solid solution nanorods through two-step process, that is hydrothermal and further post-thermal treatment. And they also studied their energy storage activity in supercapacitor and also in lithium-ion battery. And in another recent work, nickel cobalt molybdenum layered double hydroxides were studied for efficient water splitting applications. So inspired by these earlier studies, we decided or focused to identify or investigate the energy storage and also the energy conversion applications of these nickel cobalt molybdenum ternary oxides. So these are our objectives: one step reflux synthesis of this material and further investigation of the synergistic effect of nickel and cobalt and their energy conversion application as a water oxidation or oxygen evolution reaction electrocatalyst, and its energy storage activity as a positive electrode material in asymmetric supercapacitor device. So most of these earlier studies involves the synthesis process, two-step or multi-step reactions, and also only they have studied either energy storage activity or energy conversion activity. So our focus or motivation is to prepare this material in a one-step process which can be scalable, and also to study its both energy conversion and energy storage activity. So this is the experimental procedure or synthesis procedure of this material, where one-step reflux method was utilized, and mixing the equimolar aqueous solution of cobalt and nickel with aqueous solution of nickel sodium molybdate hydrate. Then that final mixture was refluxed at a preheated oil bath at 125 degrees centigrade for 12 hours. Then the final product was precipitate was washed and dried, and got our nickel cobalt molybdate, and it's denoted as this. And the similar experiments, control experiments, were also done to prepare for the comparison purpose, to prepare only nickel molybdate hydrate and also cobalt molybdate hydrate. So and we also assume that this method is a one step, and also we have not used any other expensive reagents or solvents and also protecting agents. So we assume that this method can be useful for scalable synthesis. Now the exertive pattern of this in only nickel NM and CM shows the formation of tritonic phase of the respective materials, whereas in NCM both these phases are observed, and also the magnified view or enlarged view shows that there is no peak splitting in NCM, which indicates that the successful incorporation of cobalt in the nickel molybdate hydrate matrix. And also further, a FTR spectrum shows that the OH stretching vibrations due to the hydrogen bonded water molecules, which indicates the presence of crystalline water molecules in this sample. Now the morphology analysis was carried out through FESM, and all the FESM images of this material shows rod-like morphology, and the high magnification images shows that NM has the lowest thickness, whereas CM has the highest thickness of these rod-like structures, whereas NCM has intermediate thickness, and also this material is composed of numerous tiny nanostructures, rod-like nanostructures in NCM. Now the microstructure analysis of NCM shows that here growth of 003 plane was observed, and the spot-like selected area reflection pattern also indicates its good crystallinity. Further, the elemental analysis of this material was carried out through a head of stem and EDX, and it shows the presence of its constituent elements. Now its electrocatalytic water oxidation activity was studied in 1 molar KOE solution, oxygen saturated 1 molar KOE solution, and through linear sweep voltammogram we can see that this NCM material shows the lowest over potential at 10 milliampere per cm square, also 50 milliampere per cm square current density, which indicates its best stability among these materials, and also its lowest taphel slope and lowest charge transfer resistance indicates its highest OER activity. And further, the stability of these materials was studied through chronopotentiometry at 50 milliampere per cm square current density, where we observed that NM shows very inferior stability, whereas CM shows a little comparatively better stability than NM, whereas the NCM shows much more promising stability or excellent stability than these two materials, due to the synergistic interaction of nickel and cobalt in this material, and it shows negligible or almost no changed OER activity after 50 hours. So this material, this NCM material, can be considered as a promising electrocatalyst for oxygen evolution reaction in alkaline medium. Now the energy storage activity of these materials were studied as positive electrode material in 2 molar KOH solution and 3 electrode configuration, and we observed that NCM shows the highest specific capacitance, and from the rate capability observed that CM shows better rate capability than NM, but the combination of these two materials, that is in NCM, we observed much more good rate capability. Now for asymmetric device fabrication, we also need a negative electrode material, and for that purpose we use JIP derived porous nitrogen doped carbon materials, and then this material was slurry coated on nickel foam and studied for the 3 electrode configuration as a negative electrode material. This is the corresponding FESM images of the JIP8, and this is the FESM image of the derived porous nitrogen carbons, and this material in 3 electrode configuration showed nearly 190.4 farad per gram specific capacitance and also quite good rate capability as a negative material. Now the asymmetric device fabrication was schematically shown here, and their cyclic voltammogram of the porous nitrogen carbon and NCM was compared here, and to identify or decide the potential window of this asymmetric device, which carried out cyclic voltammograms at different potential window, and we observed that after 1.6 the water dissociation starts, which indicates that 0 to 1.6 is the optimal potential window for this asymmetric device, and the corresponding galvanostatic charge discharge curve of this device shows 178.4 farad per gram specific capacitance and also good rate capability at high discharge current density of 40 milliampere per semi square. And further, the long term stability or cycling stability of this material was studied, and it showed more than 80% cycling stability after 5000 cycles, and with also good coulombic efficiency retention. And further, the energy density of this device was found to be nearly more than 60 watt hour per gram at 300 and 400 watt per kg power density. So in summary, we have successfully synthesized one-dimensional nickel cobalt molybdenate hydrate nanorod-like structures through one-step refluxing method, and we also observed that the synergistic interaction of nickel and cobalt highly influences the morphology and electrocatalytic activity and also its energy storage activity. And this material showed low overpotential for 10 milliampere semi square current density to achieve in OER, and also good long-term stability at high current density. And further, this material also exhibited promising energy storage activity in as a positive electrode material, and also the final asymmetric device shows good capacity retention after 5000 cycles and also considerable energy density at a high power density. So finally I want to acknowledge my supervisor for his constant encouragement and all other lab members, and I also want to express my heartiest gratitude to the Korean Institute of Chemical Engineers for this beautiful conference and giving me this opportunity to showcase our work. Thank you all.
질문 있으십니까? I have two questions.
Yes.
So you try to control the ratio between cobalt, nickel, and molybdenate to
No,
make the nano.
no problem. We just used 1:1 ratio.
Okay. Have you tried to control the ratio?
Yeah. We will. This is the ongoing work, so I will definitely consider your suggestion.
Okay. And your materials shows different capacitance as capacitor materials.
Yeah.
But I think the surface area is quite important.
Yes.
factor about
Yeah.
that.
Yes.
So have you
Yes. Surface area. I have not actually. I am. I want to check the electrochemical active surface area. That is means undergoing, and the BET surface area I have already planning to characterize through BET.
Thank you very much.
Yeah.
As far as I know, the diameter of and length of your nano rod may affect the electrochemical performance.
Yeah.
So have you tried to control the diameter and length of your nanorope?
We have not used any surfactant or surface protecting agents to control the size or morphology. We have just used we tried to just incorporate cobalt in the nickel molybdenate matrix and observe the change in the diameter. Length we have not we didn't any used any method to control the size, but we observed that on cobalt incorporation the diameter is reduced. Yes.
Thanks for the interesting talk.
Yeah.
So one question I have is, it's not clear to me about that. Is that the performance depending on the shape of the materials or the composition of the chemicals?
Maybe this as this nickel and cobalt, both these components are there. These both materials are synergistically interacting and improving the performance.
So you believe that that is the composition is much
Composition is much more important.
Okay, so one more comment on that then. You better check that the surface area.
Yes.
as the
Yes.
picture
Yes.
is
Sure.
showing.
Sure. Sure.
And also the shape of depending on the shape of the materials, possibly affect the kind of performance changes.
Okay.
So that probably proves your answers.
Okay.
Thank you.
Thank you. Thanks for the suggestion.
네, 그러면 시간 관계상 여기서 마치도록 하겠습니다.